Hello, everyone. I don't know what button I need to press, so I'm going to just... Oh, it was the right one. So I'm David. I work at Kraken. We are not anything to do with cryptocurrency. We're the technology tentacle of Octopus Energy. I'm also the maintainer of Import Linter, which is a tool for analyzing and imposing constraints upon the imports between the modules in your Python projects. But today, we're here to talk about domain-driven design. So could I get a show of hands? Who here has heard of domain-driven design? Okay, probably everyone. And can you leave your hand up if you know something about it? Okay, a lot less of you, maybe 10%. Also, who here is actually doing it in their daily work? Okay, oh cool, so there's a few, but like maybe only 10, and some of you are doing that. Okay, so this is sort of the answer I thought I'd get. Domain-driven design, you might be surprised to know, is quite big in other programming communities. There's several books on it. There's even a conference that is entirely dedicated to domain-driven design. And yet, it hasn't really made its way into Python, I think. And so today I'm excited to introduce to you some of the ideas, if you haven't come across it, and then give you a few pointers as to how you could actually start doing it in Python. So first, this book. It came out 20 years ago. It's by Eric Evans, and it's called Domain-Driven Design. That kind of kick-started the whole thing. Its subtitle is Tackling Complexity in the Heart of Software. And this is my favorite software book. It really is. I love it. It took a while for the ideas to sink in, but it changed the way I think. So what he says is, the most significant complexity of many applications is not technical. It is in the domain itself. What he's saying is, all of these things here, all these technical things that we spend all our time learning about and reading books about, attending talks on, that's not often where a lot of the complexity is in some software. It's in this funny thing called the domain. The domain is like the subject area of the software. So I'm going to give an example from Kraken, which is the product I work on. Kraken's domain is energy retail, in other words, sending you gas and electricity bills. And in that domain, we've got a non-technical problem. This graph here is your domestic gas usage. So you use a lot more gas in the winter than in the summer because you're heating your home, obviously. And this graph is your income over the year. It's probably much more static. Now, this is a problem in the domain of energy because energy companies don't want their customers, despite what you might think, to become impoverished during the winter. So we want to kind of smooth out the pain of that expensive period of time. Now, the way Kraken does it is it has this idea of a payment adequacy review. So this is a screenshot from Kraken, and this is a single customer's page. Each of these rows is a review that we've run to just check whether or not their regular monthly amount is in line with their consumption. And if it's not, it might trigger an email to suggest that they change what they're paying. And we can sort of think of this partly as a feature, but also there's a concept here of a payment adequacy review, which is related to some other concepts, account, payment schedule. There's loads of concepts within Kraken that we've developed in order to address and make Kraken a good tool for the domain. And you can kind of think more generally about this, and this is how people who are into domain-driven design think, which is that every software has a model inside it. It's a conceptual model. It's a structured way of thinking about the domain that it's interacting with. And the user won't interact directly with the domain. They're interacting with the model of the software. And that model is in large part what makes a piece of software valuable. So it's worth putting effort into. It's worth making it better and improving it. Now, Eric Evans says there's also a bit of a pathology in a lot of development outfits, which is that you can get a linguistic divide between the developers and the domain experts. So domain experts might have one model of the domain in their heads, and developers might have another. Or maybe just like everyone has a bit of a different conceptual model of what they're doing. They use different language to talk about things. Maybe the same word means subtly different things, and everyone gets confused. And that means that we lose the opportunity to build really good, powerful models, really rich models. So if I were to sum up what I think is like domain-driven design in a nutshell, it's this. It's a strategy where you bring the model together. Domain experts and developers work together on the same conceptual model. And then that model is something that everyone's very aware of, and they use the language of the model throughout the business and throughout their code. Now, Eric Evans loves modeling. So he does a little model of his model. This is kind of his model of his book. And you can see there's lots of other things going on, which I don't have time to talk about today. So I'm really just going to scratch the surface, just give you a few little pointers, and it's very much my take on what the first steps you can take are in domain-driven design. So, first of all, we're going to look at conscious modeling. Then we're going to look at what a ubiquitous language is. And finally, we'll look at isolating the domain. So, part one, conscious modeling. So, when we think about things as human beings, we build models in our heads. That's unavoidable. We can't think about things without having a model in our head. But we might not necessarily be aware that we're doing that. And we can maybe even confuse the model we have in our heads with reality outside. And we do this also, I think, when we're writing software. We might not be aware that we're actually undertaking modeling when we build software. It's like we kind of sleepwalk through the modeling process. We assemble all these concepts because they're the first things that we come up with that will work to deliver the outcome. But maybe we didn't even notice we did it. So I think it's really good to try and be aware that we are modelers. That's what we're doing often when we develop a feature. Let's open our eyes and become aware of it. And it's a big subject, but I'm just going to give 3 tips in that regard. So the first tip is to embrace the realm of pure concepts. So let's imagine that we're building a social network, and maybe we want to sort of store the relationship between users in our system. So perhaps we'll start with some kind of relational model like this. We've got a users table, we've got a user relations table with a couple of primary keys. Now, I'm not saying this is a good way to model a social network, by the way, but the point is we've gone straight to thinking about how to implement the model. This isn't a domain model, this is a data model. And I've noticed so often when we have conversations about how to model things, we go straight to the implementation of the model. I encourage you to sometimes take a step back and just live in the world of concepts for a bit. For example, we could model it more like this. Could talk about it more like this. It's a similar model, actually. This is a class diagram, but I'm not talking about Python classes. I'm just mapping out the pure concepts that we're talking about. There's the concept of a user and a concept of a friendship. Users have usernames and email addresses. Friendships are always related to exactly 2 users. Users can have any number of friendships. These are just concepts, but it's still valuable to talk about in that context. And this is going to be a much better frame of reference if you're going to work with domain experts, because a domain expert isn't going to have a useful opinion about whether or not to use a graph databases versus a relational database, say, but they will be able to talk about this. Maybe they'll say, well, hold on a minute, we need our users to enter into friendships consensually. So we're missing a concept here. Maybe we need a friend request. That's going to be linked to 2 users, but by the user that requested it and the one that was requested of. So this is the first step, I think, in conscious modeling, is try to live in that land of concepts. Don't get distracted by implementation. When you're having conversations about data modeling, sometimes it's just a distraction. The second point is to explore alternatives. So modeling is an act of design, and when you design, you're considering different options. So let's do that with our model. perhaps we could do this a bit differently. Perhaps there's more opportunities to make this more useful and easier to work with. So, for example, friend requests. When you get a friend request, you're going to approve it or reject it. But you probably don't want it to stick around once you've dealt with it. So in this model, maybe we'd say that friend requests are probably going to be modeled by, once they're approved, then they would go away somehow. I mean, in practice, maybe deleting them from the database, but in a conceptual sense, they just don't exist anymore. And maybe we would like to be more explicit in our model about what's happened to friend requests. So we could add a status field, say. And now we can tell things about that friend request even after it's been dealt with, whether or not it's still waiting or if it's been rejected or accepted. And, we can keep on exploring this conceptual model and thinking about different ways to do it. Maybe we want to have a stronger relationship from the friendship and the friend request. It's quite implicit at the moment. Maybe we could say, yeah, a friendship always has the friend request that originated it. Or maybe we look at this and go, oh, there's something a bit funny here, like a friendship is related to a user, but also they're going to be the same users as the friendship's related to. Maybe we could just get rid of that, maybe. And that's like a bit sort of a tighter model. But I still don't like this model, personally. It seems to revolve conceptually too much around friend requests and not enough around friendships. Maybe we could just combine those two together. Just have a friendship that's got that status, that requested status. Suddenly, for me at least, I look at this and I'm like, oh, I think I might have found it now. It's very kind of efficient, this. It's quite simple. There are less moving parts, but it does everything that we want it to do. Notice as well, like, even the idea, the concept of friend request is gone. Now we've just got requested friendships. So that's my second tip. Keep on exploring alternatives, and you might find that you get something nicer, simpler, something that more ergonomic. Final tip, seek early review. So let me ask you this. I want to see if anyone relates to this. So you're working on a feature, and it takes you a while. Maybe you've been working on it for about 2 weeks. You get it so it completely works, and then you put it into code review, and then the person that reviews it says, okay, this is great, but did you think about doing this? And what they're suggesting kind of cuts to the foundations of what you've done. And you're like, yeah, that is actually a good idea, but I've kind of done it now. And it is better, I agree, but it's not really another 2 weeks better. I have to start everything again. Can anyone relate to that, either as the reviewer or as the coder? Yeah, I mean, me all the time. It's so depressing, isn't it? And I think often what the problem is actually that reviewer has thought about another way to model it that would have been worth exploring, but they've come along too late because that model is the foundations of all your work. So it's simple. Let's just review our models before we dive into doing all that expensive, time-consuming code. It's not complicated. Just write it down somewhere. Say, this is how I propose we model this particular feature. These are the concepts. Here's a little diagram. Here are some other things I considered which I don't think are as good. Pros and cons, things like that. Get some feedback. Okay, so to sum up with these, embrace the realm of pure concepts. Don't stand in front of your words. Explore alternatives and seek early review. Okay, part 2, ubiquitous language. So remember this diagram. Remember I sort of said that the language of the model needs to kind of pervade the whole business. This is what Eric Evans calls a ubiquitous language. Ubiquitous means ever-present, appearing everywhere. And so what he's saying is it should be present in the language in this model should be present in our conversations. It should be present in the tickets that we write. It should be present in our code. It should even be present in our user interfaces. It should be everywhere. And I'm just going to give you a little example with imagining that we've now developed a bit more of this social network. So let's say we've built it and now we've got a new feature, show recent friends. Add a section on the user's homepage showing their active friends in alphabetical order of username. Only users who've logged in the last 2 days should be shown. And then there's a wireframe with the recently active friends. So let's say we did use this data model, and let's say we used Django. With Django, you get a Python class which maps on to each database table. So we've got a user, and we've got a user relation. Unfortunately, these are called models. That's one of the annoying things about Django. It kind of uses model kind of for a data model. But anyway, so what's the problem with this? It's not using the language of our model. We've already got a name for this, friendship. Let's rename it to friendship. It sounds like a banal point, like obviously I deliberately chose the wrong name. But actually, I think that does happen in real life. Often, you've got a mismatch between your code and the language people talk about. So just refactor it or start using, just bring it in line with each other. I'm going to give a slightly more complicated example. So don't worry about reading this, but this is a Django view. So it's going to take an HTTP request, return an HTTP response, and this is what is assembling the active friends and putting them on their homepage. So we're just going to zoom in on the bottom bit. We'll come back to the other bit later. What we're doing here is we've got the user's friends into what's called a Django query set. That object there is friends. And we're filtering it by the ones that logged in 2 days ago, as per the ticket. Now, filtered there, users, filtered. It's all a bit kind of hand-wavy, isn't it? We're not really naming things very well. And you might say, well, naming things is hard. That's what people always say. My take on it is naming things in code is only hard when you haven't done the modeling work yet. If you've done the modeling work, you've got names for things, and it becomes a lot easier. So let's return to the ticket. Show recent friends, active friends, recently active friends. We haven't actually done the modeling work yet. We haven't got a name for this thing. Let's speak to the domain expert, point it out, and work together. Let's call it active friends. Now we've got a precise word for the concept we're talking about. We've even changed the wireframe. Now, it's easy. We just rename it to active friends everywhere in our Python code. This isn't complicated. You just have to make sure that you do the modeling. So that's ubiquitous language. 3, isolating the domain. So Eric Evans says, to apply our best thinking, we need to be able to look at the elements of our model and see them as a system. We must not be forced to pick them out of a much larger mix of objects. So what he's saying here is, models themselves and the business logic within them can be quite complex. And so we need to do ourselves a favor and not mix in all those other technical issues and give ourselves a chance to be able to think clearly about them. And so what he says is, try to isolate the domain logic from all that other code. This view here is an example of non-isolated domain code. This logic here is redirect logic. If the customer isn't logged in, you redirect them to a login page. This logic here is just plumbing. It's all the stuff in the middle which we're more interested in, and that's a good candidate for isolation because we're getting those active friends out of the database. So this isn't complicated. Let's just create a different module called domain, say, and have a function called getActiveFriends. We'll move all that code into there, and then now we have a more isolated domain, or at least we've isolated our user interface logic here. Notice I've also moved the ordering logic out of the domain because ordering isn't really domain logic usually. It's just about the presentation. Okay, so a slightly grand idea for grand name for what we've done is we've made a little layered architecture. But all it really is that we've got a user interface layer with our views.py and a domain layer with our domain.py, and it calls into it. It's not actually a big deal. Let's look at this domain logic, though, a bit more. Does this look to you like business logic? I hear a lot of people using the word business logic when actually they mean logic. But business logic, domain logic, this is stuff that people who are non-technical will be interested in. And there's a lot of technical stuff going on here that's very coupled to our data model. So let's do the same thing. Let's push the data logic down into another layer. Call it the data layer. It happens that Django asks you to put this stuff in a models.py, but don't let that distract you too much. And so say we could put it on a class method on our friendship class, so that now, this is looking a bit better, isn't it? GetActiveFriends, our domain logic, this is much more like domain logic Friends equals friendship.getFriends of the user. We could do better, though. I think there's still some Django leaking in here. Like, if the domain expert were to read this, even if they knew a bit of Python, they might be a bit confused. You know, what's that GTE, for example? It's not that easy to understand. We could push things further and adapt our Django logic. I'm not going to show you how, but like, you know, this is an example of what it might look like. 2 days ago, you know, we're really calling it out by naming it as a variable, and then friends.loggedin since 2 days ago. Let's look at this final version of the function now. This is a good example of an isolated domain. Not the only way to do it, but I think you know that you've got it when someone who is a business expert will be interested in everything that's going on in that code and is not seeing distractions elsewhere. Now, I should say, don't take this particular architecture too seriously. I don't even like this architecture, to be honest. There are other ways to do it. Domain-driven design is not an architecture. It's easy when you read the book to think it's an architecture book, but it's all about concepts and like people and practices. So some people prefer to do something more like this, where the domain sits at the bottom, has no dependencies, and everything depends on that. You might have heard this called onion architecture, hexagonal architecture. I don't have time to talk about it now, but fortunately, there's a very good book, which is written by him, Harry, so you can talk to him afterwards, and mostly Bob. It's a really great book, and it talks a lot more about all these things. So I'm going to close with 3 calls to action, because the truth is, you don't need to ask anyone's permission to start doing this. You don't need organizational change. You don't need to re-architect your code base. You can start with a mindset shift, you know, next time you're at your desk. My first call to action is in the next feature you work on, draw a diagram of the domain model and just make it conceptual. Explore different options with a domain expert and then use its language throughout your code. My second call to action, in the next code you write, try isolating the domain logic from technical or user interface concerns. Final call to action, read the book. It's really good. I love it. I keep on reading it. I learn more every day. This book changed the way I think. If you read it, perhaps it will change the way you think too. Thank you. Oh, I have got time for questions. I didn't realize. Does anyone have any questions? Silence. Yes. Yeah, so the question was, if you didn't hear, this person finds it difficult to understand the book. Is there something more succinct? So this is actually often an accusation leveled at this book. I think it takes a bit of skill to read it. The problem is, it's unlike any other software book you've ever read. And the penny dropped for me when I realized it was a book about concepts and not about organizing code or things like this. So like, maybe give it another angle and try again. But nevertheless, there are lots of things I miss and don't understand, and it's almost like a kind of holy book that keeps on unfolding its mysteries as you return to it. I did go on the domain, like Eric Evans's website, and there is an executive summary of the book that is like freely available that I think they wrote for like executives who just want to read like a few pages. So you could like just Google for Eric Evans, and probably that will lead you in a good direction. But you're not alone. Lots of people feel like that. I have tried to read some other books which were more about implementing it. Personally, I found them a bit too focused on Java and architecture, and like for me, this spoke to me a lot more. But,
don't think we have time for any more, but next session is in 5 minutes. So, round of applause.